All right, good morning again. People are joining. I'm going to start by talking just a little bit like this, and then I'll start sharing my screen. So happy Friday. We are at the end of week 3, and we have great weather today in Pullman, and I know most of you are here. And so today is midterm 2, and so I am going to talk about it and release it and clarify if you have questions. That's the purpose of it, and we may not need to use the entire time, but whatever question you have, whether it's on the exam itself or anything else about the course, is a good time to ask. And so that's why I began by having to just have a conversation like this before I start sharing screen. There's no formal lecture or anything like that. James is there, so help out and answer any questions you may have. And so this is going to be an informal discussion, and as I said, if you have questions, you should feel free to ask. Let's do our usual thing during the warm-up question, just one today. And this is going to be a random question, purely random question. I want to know what your all-time favorite movie is. All-time favorite. So sometimes it's kind of difficult to remember and go back in old days what you saw, and the most recent thing may come to mind. But I just want to know, what is your all-time favorite movie? Go ahead and do your participation. This one is going to be a little tricky for me because these other kind of questions I have had so far would make me count. So there will be 5 things, and then I just start to beam people and count them. This is going to be a long list. So I am putting myself for the Oswald post I will send later today, which is going to be a long list of things. But if you guys have similar tests and you're going to kind of share, then there will be maybe some movies that will show up more than once. One other thing I want to say is, because we are going to start discussing like this now, before I start sharing my screen, if you feel like, go ahead and turn your videos on. I don't see anybody's video on. I have my grid in front of me, but you can go ahead and do that. So you know, feel free to do that. And whenever you have questions today, you should make sure that you unmute and ask questions. So that's what we're going to do. And I'm going to start sharing my screen. Those of you who have come a little bit late and joined us, we are writing what our all-time favorite movie is, and so people are responding, and I have liked the way your participation so far, and I'm hoping that everything is going fine. So go ahead and do that, and I will be starting soon. Before I get started and talk about the exam and kind of address clarification questions around it, let me give people to 30 seconds or 1 minute more to finish this question, and then I would clear that up and just want to know how you feel you're ready. So just on a scale of 1 to 5, I feel prepared, I feel ready, and things like that. And that one is not going to be something you need to worry too much about, but I want to know how well prepared you feel like for the exam that you'll be seeing now and you will be submitting after 24 hours. So I've not cleared up the question on the movie. Oh, okay. People have started on that one. So there is number 1 to 5. 5 is well prepared, and this a low number would be not so well prepared, is what it means. And I'd like to see many 5s, just so you know. Okay, so let me. Good. There are all kinds of numbers. This is perfect. So we have good preparation. Let me start sharing my screen. Before I start sharing my screen, is there anybody who wants to ask? By sharing my screen now, I meant to go through the questions so you know them. And if there is anything that's not clear, then it will be clarification type of discussion. That's what I will open it up. But before I do that, anybody has got any questions for me before I get started? Okay, you can keep answering how well prepared you feel like for this exam. That will be take home. Take home exams are fun. Okay.
So on Oswald, the exam says it's due at noon. Did you accidentally set it at a different time?
Okay, so let me explain that. So this tells me people have gone out and so on Oswald, which I am very happy about. So the exam is out on Oswald, it is posted there, and 24 hours was what I thought I would give you. And so 2 p.m. is the grace period I have. I have noticed that some people sometimes have internet connection problems and so on. So I wanted to give the maximum time I can kind of give for any allowance for things that have happened. So if you are careful about that time, the 2 p.m. that I have written on the exam itself, on the prompt itself, will be the last time you need to submit. So if I have said noon, then it's because I probably have stuck to in my mind to the 24 hours. So by 24 hours, I mean from the time it is released to the time you submit. And so there is a little bit of a grace period that I have given you. So if that was a question, then you should feel free to submit by 2 p.m., latest by 2 p.m. Tomorrow. Any other questions? No, there is no place where it says midnight. Does it say midnight? No, I don't think it does.
So where you actually go to submit the exam,
yes,
that is midnight.
Okay.
So like, yeah.
Okay, then that one I have to fix. Thank you for pointing that one out. So there are certain things that are by default set on Oswald, and I probably have neglected to check that box off. So I'm going to go ahead and change that one. It's not midnight. If you are okay with me, let me go ahead and immediately change that one before I start sharing my screen. But I can do that later on, I think. But let me just go ahead and do that right away. Okay, it's now fixed. So it's 2 p.m. tomorrow. Any other questions before I go there? I share my screen. By share my screen, I mean I'm going to pull out the exam prompt and kind of we together see the questions. Those of you who are on Oswald there, you can see it for yourself, but I want to have us a common thing to see and address any questions that are about clarification. That's what I will be doing. But before I get there, anybody has got any question for me? All right, so then I'm going to go start sharing my screen.
I got a quick question.
Sure.
On number 3, it was given an explanation of a interpreted.
So this is what I will do now. So if you have a question on the kind of the clarification questions on the exam prompt, the questions itself, that's what I will go through now. So we can maybe see if there is anything before we get to question 3. Okay.
Okay, go for it.
Yeah, so I have now open and you all can see my screen. I actually want to begin with the instructions. It's not a bad thing. So you've got the most important things that you need to see, including the correct time for the due date, and that's 2 p.m. in the beginning. And so you have this instruction, and then the next page has got the questions, and that's all. There is only 2 pages to this one, and the questions have got points written on them, and so there are 4 questions, and 2 of the questions have got A and B. So make sure that you do them. And so when I have set up the Oswald grading, we have like what we've been doing for all the homeworks, you would see that there will be points that you would associated with each one of them. And so if there is question number 1 that has got A, B, C, then the A will come separately, the B will come separately, the C will come separately, and all of the points will add up to 100. You are going to produce a PDF. And so the submission that you see on Oswald when you go there will allow you to submit only a PDF file. This PDF file might be something that you generate by typing, and you may type in LaTeX, which is what I do. You may type in Word, that's fine, whatever else that you have. And if you produce a PDF that is generated in this fashion, that would be great. If not, you may choose to do things by hand, just like we've been doing with the homeworks. And if you do that, I would like you to do a good job on scanning it so that we don't have to worry about what was written and so on. And make sure that you write legibly, generous space so that it becomes all clear, and what you have done will be evaluated in a good way. 2 p.m. is the time. Before I read number 5, let me tell you what I mean by this time. So in some ways, it's take home. Open book exams are sometimes, they kind of test a different kind of thing, how much you can apply a problem, much like what you've done with homeworks. And so don't feel like you have to use all of this time. You've got other things to do. You will go right to class after this one. And so do it in a manner that would give you the largest chunk of time to sit down and work. That would be my best advice to you. And if you do that, then you will see how long it would take you instead of interrupting it and so on. Maybe something may require you to think a little bit and then you can come back and finish it later on. So the 24-hour period means you've time a little bit to work around according to your schedule, according to how your days are going. Sometimes there will be a place where you may need to think through what you have thought about in the first time and so on. Otherwise, the best advice I have for a take-home exam is to dedicate a chunk of time that will be free for you. And that freedom is what you get now by having it. And as I said, I got that extra 2 or 4 hours, however you may interpret this one, for those who may have some issues and so on. I would not tolerate anything that will be a late submission on Notesable, and this is an exam and I want you to take it seriously. There is a reminder. I don't feel like I need to emphasize too much on this one, but the syllabus has got a clear statement on academic integrity. I have complete confidence in you and that you will be doing your own work. This is an assessment, and therefore what my expectation is that you will be working on your own and you will not be collaborating with anybody else or discuss or anything like that. This is your work, just like you've been with academic integrity with your homeworks. I expect that one to happen for this as well. So I needed to remind you this. If you need to check what it means when it is violated, you can go back and look at what the syllabus says on this particular issue. But I have, as I said, no assumption of having to worry about that one. So go ahead and do all your own work. Now I can go to the questions. And so let me first give you the high level one. So you probably have already seen them. You're eager as much as I would expect you. The questions are 4. 2 of them would take you back to time before spring break. That means before we started doing things online. And 2 of them would take you things to have been doing after we have started come back. And so I'm going to watch out if there are any questions. And that's what I was dragging my chat window to another screen. So there is a separation, 2 questions before spring break, 2 questions after spring break. After spring break, we had discussed Turing machines and decidability and undecidability. The very last 2 lectures we had were on undecidability. I chose not to include them because they were too recent, but the other ones are included. And so the first 2 questions that you would see now will take us back to before spring break. And the first question is on context-free grammars. And so you've got something that you probably would remember from homework 5. Before I actually go through these questions and invite if there is anything that needs clarification, a good rule of thumb to remember this one, how to prepare. Those of you who had a 4 and a 5 for your preparation, you're well prepared, and so you're good. Homework 5 and homework 6 will be the 2 homeworks that the subjects, the topics that are covered that this exam would also cover. In addition to that, you've got the decidability, section 4.1 in the book. And so this one would go back to Chapter 2, Section 2.1 on context-free grammars and about ambiguity and so on. So you've got a nice little grammar English for and given here, and you have 3 pieces of questions that ask you to show leftmost derivation. The first one asks you to do leftmost derivation for a given sentence there that is current, and you will be showing that. And so this would require quite a bit of writing, and so you'll have to go through that and write. And then the next one will be the B part of the question would ask you to make this one fix it, making it unambiguous. And then after you've done that, then you will show that the sentence that's given in C is in fact now has got a unique leftmost derivation. That's question number 1. I guess a good way to get whether somebody needs clarification question is to ask for me to give a break and then say, is this question clear? Or should I just go run through them? What do you think, James? Okay. Okay, so question number 1 is clear, is what I would imagine. The next question is about the context-free grammar, and it is going to be turned into a push-down automaton. We've seen a couple in the exercise in homework 5 and homework 6 to doing exactly this type of thing, when you have a context-free grammar, to turn it into a push-down automaton. This particular context-free grammar is called JH Lisp. And I've told you at some point, we'll tell you, because this JH Lisp has shown in several homeworks before. And so I'm going to let James explain what, the story behind what JH Lisp is. But let me first finish them, and so he can come back and do it, so that I don't have to come to questions 3 and 4 later on. And that probably will be a good place for you to get to think about if there is anything that needs clarification. So question number 2 has to do with changing a context-free grammar and providing a push-down automaton for it. There is the slide I had in the last lecture would remind you which lecture covered this topic if you need a reminder, but I'm sure you are all aware of how to do this. These 2 questions, question 3 and question 4, are the ones we have covered after spring break. The first one is about Turing machines, and notice that they are being asked now to give an implementation level description of a Turing machine. So there was high level descriptions. We have spent some time talking about different types of or problems in which we have given Turing machine description. This one requires you to do an implementation level description. And so make sure that you are aware of that and give that level of detail for these 2 problems. The last one is the one that is not covered by any of the homeworks we have seen so far. And this is one of the most recent topics. It is about decidable language. And you have a fairly clearly stated problem, and you're going to show that this language is decidable. All right. I'm going to invite James to tell us why this one is called JH Lisp and because you've encountered it several times, and I think it will be a fun way to conclude. I'm not sure if we're going to come to this genesis of problems in other upcoming problems, and we have seen it at least twice, and this is the 3rd time you're seeing it. I'll let him explain it, but before I do that, anybody has got any questions? You had a question on question number 3?
There's a whole bunch of questions in chat currently.
Okay, a whole bunch of questions. So let me then go see what those questions are. Okay. Yes, so it is an open book. And so you are free to reference past lectures and slides. This is correct. So question number 1, it's an open book. Take-home exams is by nature an open book one, so you are fine to open to look up. On number 1A, can we show trees or a proof? Let me go back to what question 1A is. Question 1A. Well, no, I would like not trees, but written out. There's what rule is, what variable is replaced by what, and so you have that development. So I think it will get messy if you are going to do this thing in rules. So I have answered that question. That was Christian's question. Do the underscores actually matter as inputs? That one I don't understand. Which underscores?
Okay, so in JH Lisp for here, right, I have used underscores instead of spaces because I've noticed that some people have not necessarily always noticed that there are, in fact, spaces between the arguments. So for this test, I don't really care if you have an alternative method of displaying spaces here, as long as the terminal space character is in some way represented. But yes, they are a part of the language, just as the parentheses are.
Okay, this will be a perfect place, James. I know there are more questions to answer. I know I have seen Jasmine's question, and so there are a couple others to answer. We will answer them. I think it would be good to know what is up with JH Lisp. Why don't you tell us what it is? How did the name come about and what it is?
For those who haven't figured it out, JH is my initials, so that's where the naming comes from. But the idea for this language originally was when we were first going over regular languages, I wanted to figure out a way of testing what all you guys thought would be capable of being parsed by a regular expression or not. And I remembered a very old text post on the internet about people trying to parse HTML with regular expressions, which you can't like determine if something is valid HTML with regular expressions, although you can usually use it to find substrings in it. But I thought, well, what's a more interesting way of describing this? So I'll take Lisp and just take a subset of it, say only the ability to calculate arithmetic expressions. So what you're looking at is basically the Lisp programming language if it only had plus, minus, times, and divide. Mm-hmm. And I said, can this be parsed with a regular expression? The answer is obviously no, because a regular expression can't count the parentheses, and this thing allows you to nest expressions. But it is parsable with a context-free grammar. So on the next homework, when we were dealing with context-free grammars, I figured, well, might as well throw him a problem that's not from the book, give him J.H. Lisp again. And the way I presented it to you, it was mostly in a context-free grammar from the start. What it did need was to be, I guess, formalized. After that, it was trying to put it into Chomsky normal form for the same reason as the previous problem, which is to give you something that is not from the book, so you have a bit more variety in these problems. And here, I'm asking you to convert it into a push-down automata. The only thing I've really changed is that with spaces, I've displayed them as underscores because I want it to be known that this is, in fact, a part of the language. Because if you think about it, right, if you have a... if you did not have spaces between the arguments, right, then say between two expressions, such an expression can be either a number or another expression, right? If I write plus 2, 2, or plus 2, 2, 2, right? How do I know if it's plus 2, 22 or plus 22, 2? Because there's no space in between it to differentiate between the operands. So in this case, I'm using underscores, but if you have another way of, say, displaying a space on your push-down automata, go ahead, as long as I can tell it's a space.
Okay, so that was a good explanation. Thanks, James. And I hope this also gave you a little bit of a background for how the Lisp is a language. I know some of you might wonder even what it was, but Lisp is a programming language, one of the old ones, and the book makes a reference to it. In one of the lectures I mentioned it when we talked about Turing machines. The next question I have is, what kind of, and I'll come back to Jasmine's question, what kind of a description counts as implementation level? When we talked about Turing machines in the second lecture, I think I remember it was, we said we are going to kind of, if we cared to go to the point we have done for DFAs and push-down automata, we would describe a Turing machine with the 7-tuple with the transition diagrams and so on. That would be extremely complex for anything. But in the transition to that, there were a couple examples we saw where the description is low level that could help us identify what those states are. So to very, very concrete example will be example 3.7 in the book. That will be an implementation level description that kind of has got stages which would take you you go to the right and to the left and across of every other zero, and so that description for what a Turing machine would do to decide a language that's a zero, what the length of that is a power of 2. That description is implementation level. There is a lot of detail there. In fact, the whole point was to say if we described it to this extent, but then we can take that extra step and try to draw, the complete state diagram for it. You're not asked to do that, but unlike the other ones which are at a high level, this is the level of detail I'm looking for. So a good answer for it will be take a look at example 3.7 in the book, and that is what the level of description is. Jasmine's question is, for 3, are all the F's and before the T's or any one of them in any order? Let me see if the order was important there. The F and T there are true and false, by the way, if you can, it doesn't matter, but so they are, no, it's just a number. James, do you agree?
Hold on, is what just a number?
The question number 3. Yes, this session is being recorded.
For the number, the F's and T's, right?
Yes.
The descriptions of the language only says they contain twice as much or not twice as much.
Yes, but is order important? The order is not important.
Yeah.
Yes. Okay. Christian asked if this session is being recorded. Yes, it is, and I'll make it available when Zoom makes it available. Thanks. And anybody else, any question?
Real question before we move on from the Turing machine question.
Yes.
You said in the book it's the example 3.7. Is that the state diagram for it?
No. So the state diagram is given, but there is the example has got a description for M2 that is in English in words.
Gotcha. So it's just that.
That is what I mean by the implementation of the description. State diagram is not something we have asked. And there is a gap between that description and the state diagram. You would have to figure out quite a number of things to actually draw a state diagram. And it is unnecessary to do that. So, cool. so M2, the way M2 is described is what I mean. Anybody has any other questions?
Yeah, I wanted to ask if we could use a multi-track Turing machine.
I don't remember having a need to do that. Where are you inclined to doing something like that?
For number 3, part A, I just thought of a solution that would be convenient to use 2 tracks.
So I would be curious to see how your solution would come. So this is why I actually like having to think through things like this and have a discussion for this exam or for problems, because we have established that adding track tapes to Turing machines is not going to add power. And so theoretically, what I have in mind in both of these questions around the Turing machines is you will go with the standard one. And so you could make it easier, like the example we saw last time, where we had to run 2 machines in parallel. And so the Turing machine that one going to run them, we said, oh, it doesn't have any problem because it can have 2 tapes. So I would prefer a solution on this one with the standard Turing machine. But I would give extra kind of, thumbs up or something if you say, alternatively, it could be shown with multiple tapes in this fashion. And therefore you can see that it takes shorter to describe or something like that. But what is being asked here is to work with standard Turing machine with a single tape. Does that answer your question?
Yes.
Great. Anybody else, any other questions? So there shouldn't be any place where things are, by nature, this course and the kind of things we have require kind of precise statements around things and so on. So I don't expect any place where things to be, interpreted in different ways. But let's say you come across on some place where you have doubted, you can email me and then ask for clarification. I would allow that. But if not, then you can also state your assumption and base your solution on that one. I'm glad that the multi-tape question was asked now. So I would prefer to have a standard Turing machine for this solution. But I would accept if additionally somebody shows me how it would be done when there are multiple tapes. But if there is any place where you have doubted and then there was one interpretation you took, if you state your assumption, you show, okay, this is my general statement for every course I teach. A place where things are ambiguous, if you tell me how you have interpreted it, I would be willing to see what your assumption was. But I don't think there is any place where I can imagine something like that to happen in these questions. For question 4, can we use theorems from the book? Yes, you can. I'll have to, right, yes, you can. If there is, I would prefer to make the theorem to say what it is showing. So if there is a statement made about a certain membership in a certain language that is proven, call it by that, rather than give me a number, a theorem number. And I know what you, I hope you know what I mean. Tell me what the result is. So for example, ATM is undecidable. We've worked our way through that statement a couple lectures long. And so instead of telling me theorem, some number, then you could say ATM is undecidable. Using that result, then we can show this. That's fine. Anybody has any other questions?
Just a general question. As we're working through this later, you know, maybe we don't have a question now, but we come up with something, some problem as we're going through this later. What would be the best way to get a hold of you or James?
Email.
The fastest response?
For fastest response, do email. So I have been wanting to, in the syllabus, I say, if you have a question related to the course, use the, you know, the mail through Oswald. It comes to my marks, but I would know exactly where it is. So that would, I would pay even more attention now. You would be surprised, just like everybody else now, if you go to anybody's email, there is like 10 times what it used to be before. And what it used to be before is like 1 million. And so now I've got 10 million emails coming. And so I don't want to lose sight of an important question that's very time sensitive. So for that reason, I would prefer if it comes through Oswald. But if you make it clear to me that, you know, I should pay attention by having the subject clearly saying this, then I would accept through email. So email will be the best way to reach me. I think with this discussion we're having now, I am pretty confident that the questions will not have an issue that needs clarification, but I cannot make that statement all the time. I mean, something may not be clear. And the questions that are allowed to ask by email would be clarification questions. What do you mean by this? Not how do I solve it? That is obviously not something I would help you with by email or some other way. Any other questions? You can take a minute more to see, you know, I have given you an overview and the prompt is right in front of you, and maybe on your own computers, maybe you have opened it with larger font sizes and then be able to see. But I think they are, we managed to get them on one page. It's nice to have all the problems you need to solve on one page. You should be in good shape. All right, if you do not have any questions, I'm going to, you know, wait, we can, I'm not in a hurry to finish off. This was how I thought, I knew we would not probably need the entire time. But if you want, I can pull up the slide that I have from the last lecture, which shows us what weeks are left and so on, to see where we are headed. But I don't want you to lose the chance to ask questions for clarification here. And I don't want to take your attention to something else right away. So let me give you a minute to think, or half a minute to think if there are any questions you have. Okay, it looks like all of the questions are clear. So what I would very quickly show you is this page. Let me see where we are. So we have done, I hope you're seeing, I don't know what you're seeing now. I think you're seeing something else. I should swap. Okay, this is what I want to show. So we've finished week 3, and so you will be giving this one tomorrow. And so we have another 3 weeks of lecture, and then the finals week. We are done with chapter 3 and 4 in the book. That's Turing machines and decidability. When we come back on Monday, we'll start talking about reducibility. That's chapter 5. We are not going to finish all of the things in chapter 5, but we'll spend a good 2-3 lectures talking about reducibility. That's an important one. And we'll maybe kind of get into a little bit of week 5 for that, but hopefully we'll finish everything we need to finish from that chapter in that week. The other topic we have left is interactability. And in the book, it's kind of late, but I am going to have a very light treatment. So the first 2 parts of the book is what this course is about. Regular language and Turing machines was chapter 2 and 3, and decidability. And then we moved to Turing machines as the second part. The interactability part is the complexity theory, which will be not really part of this course. But I want to tell you about complexity classes and interactability. That will be something we'll do a little bit of part of week 5 and part of week 6. And we'll use the last lecture day to wrap things up. So we've got 2 homeworks left, and homework 7 and 8 are as planned. You can see them when they are in and when they are out. And my current plan is to still have the final also be take home. Whether it's 24 hours or more than that, we'll yet to see. But this is where we are headed, and I think we are in good shape in terms of having what topics are left and what homeworks are left and things like that. So this was the slide I wanted to show you, and I'll leave this slide for a second and see if there is anybody who has got any questions. Otherwise, we don't need to wait until 11. You can use the time to work on your exam if you like. At 11 a.m. today, there is a town hall, and if you don't have classes, I think you can attend. The WSU president has got a town hall that I think is open for everybody, of course, and if you don't have classes, you may want to go there. Anybody has got any questions for me or for James? Okay. All right, then I wish you all the best. And the moment you're ready, you submit. If you are done, then then you are happy with you, give it a proofread and things like that. You don't have to wait until it is the due time to submit. So submit anytime you're ready, and make sure that you do it on time, and make sure that you write legibly if you are going to handwrite it. If you are going to type it up, then perfect. All right, I think I have given you enough chances to ask me questions on the exam itself, so it looks like you don't have. I'll tally your or report on your all-time favorite movie, and you will hear from me. And so there is no slides to post today, but the recording will be posted when Zoom makes it available. Okay. Stay safe, stay healthy, and do a good job on this exam and make me proud. And I will see you on Monday, okay? Thanks.